and usually these applauds are given after the talk, but it's always good to get in advance so that you don't have a risk of not getting it later. So thank you, Dr. Vijay, for giving this opportunity. I see my very good motivator, Dr. Akbar Shah. In fact, I will admit and I will appreciate, and you all must know the story of this society. It is the idea which was conceived by Dr. Akbar Shah, and not idea. Many people conceive idea in the night maybe, and then in the morning they forget it, and very few of them they take it forward, and after taking it forward from 1 or 2 miles, maybe 10 miles, maybe 100 miles, they get tired and then they leave it. But here is the man who conceived the idea in the night, remembered it in the morning, talked about it, and then nurtured it, and today what we see is one of the most active society. When I say most active society and most impactful society, I mean that is not the number which matters in a society, it is the number which are effective, it is the select number which are impactful, which will change the direction of the society, which will change the direction of the science, and that is what this society is. So I see a lot of young generation here, and I feel that this young generation will take this society, the vision of this society, and stalwarts like I can see Dr. Reis and Dr. Mohanan is here, Dr. Vijay is here, Dr. Idris is here, Dr. George, and of course Shrijit, who is and of course the director of this institute. And Shrijit I was not knowing before, but the perseverance which he has matches with the perseverance of the society. So thank you, Shrijit, and everybody here. I will just will be talking on in just 20 minutes, which is I must say that this 20 minutes is just a trigger. It is not a talk. I would say this is just a sensitization, what you say. And the alternate to animal experiments need, all of you know the need, but I will just put some points. And what are the challenges here? And what should be our strategy? And everything, when you want to change the perception, the thinking, the policy of a particular straight road, and you want to shift to other, you have to have why you want to do it, how you do it, and how you will sustain that. And that's why strategy is always important. And then what should be the way forward. So this is my thinking process, but you may have a lot of other ideas, particularly the young generation which we have. What I see that when you are looking for animal experimentation, usually you can consider there are 4 dimensions of this. One is the scientific dimension. Why you do animal experimentation? Because you want to search what is matching with human being. And that's why you want to do the pharmacokinetics, you want to do the pharmacodynamics. Particularly I am referring to the translational point of view. And if you are a zoology student, you want to see that this heart works like that, this heart has a 4 chamber, this RBC has that, and HB1AC reflects the blood sugar, which I can see here, and so forth. You start from anatomy to biochemistry to morphology to histochemistry and so forth, because you know that some degree of there is a similarity of genetic profiling between these animals and the human being, and therefore you use that. And there is a need of, and I am not going to the need of animal experimentation, which has started right from the development of the several drugs. Maybe you can talk of insulin, you can talk of heparin, you can talk of a vaccine. Nobody can deny the contribution of that. But then you have to also think the developing or the changing profile of the science. The science is ever-changing dimension, has an ever-changing dimension. The science is now changing. Can we develop from that larger animal to smaller animal to single cell? And maybe you are looking at the DNA, RNA profile, and then can you translate this information to the larger scenario? And with what accuracy, with what translational value? And when you do so, you always look that what is the caveat in this? That this information we are translating, but we are missing this information. And if you are missing this information, which is called as a missing curry, then what can be the connectivity of that? So that is what the science. We talk of sentiments, and this is, I think, what is the difference between the human and the robot? The robot is more intelligent sometimes than human. They're faster, they're more accurate, but they do not have sentiments. Maybe in future we will have a robot which will have a sentiment as well. But as on date, no robot can match the sentiment of human. I was using during my MD days the experiments on dog. And every day we used to sacrifice a dog for our experiments. And when I had a pet in my house, then it was so frustrating if I translate that this my pet dog who sleeps with me, eat with me, and I am dissecting him just for the information which is already available, I would say, because it was not so novel information which I was doing, but it gave me publication in British Journal of Pharmacology, that's no problem. But then, if I translate this, and it really frustrates. And therefore, the same sentiments. We have a sentiments, we agree, but they also have a sentiments which they express sometimes with their eyes, their tail. And my present dog doesn't have a tail. Is a French bulldog. It doesn't have a tail. It can't put like that. But the expression which it gives from his eyes, from his body movement, tells you that they have a really sentiments. And that's what is important thing. And ethics is a very important issue here. The third dimension. Everything is justified in love and war. But it also has an ethics. And everything is justified in science, provided it is justifying the outcome for the larger humanity. And there is no alternative for that. So that is the ethics. And lastly, what we talk about, the alternatives. Do you have an alternative? Can you think of an alternative? If you can't think of why can't you think of alternative? And then, can these alternatives change the entire scenario? So these are, I call them the 4 dimensions of this. All of you will be talking, maybe knowing about the why experiments. We can debate on this. The biological similarity, short lifespan, because human lives for maybe 60 years, 70 years, now 80 years. But the same thing you can convert into maybe shorter time, maybe if you are using rat, maybe for 2 years or 3 years, or maybe. And controlled atmosphere, it's very difficult to control atmosphere for human. In clinical trial we do that, but to a very limited extension, limited possibility, inclusion criteria, exclusion criteria. But when they go into the field, they are absolutely different human being. And then, why not experiments? Also important. We say sometimes they are futile. Are they futile? Perhaps yes, perhaps no, because there is many times the information we generate from the animal experimentation is not translation, but it is many times. That means many times it does. Therefore it is, and also they are painful and they are done in a non-consenting living being. Today, consenting process, informed consent for doing clinical trial is a legal mandatory requirement. But do we have that system here? Perhaps we cannot have. So this is what is thinking. So this is something which we have to keep a balance on this. I always say that these two are the two different disciplines, and there is no need to fight between these two disciplines. There is a need to understand between these two and tell those who are using animals that don't use animals, use 3R principles, and if it is a must, then use it. If it is a possibility of alternate, then forget about it. And at the same time, they should not say that no, this is isolated experiment, this gives information only in a cell, and this is a body which is a complex body, not only cell, but organ, not only organ, system, not only system, this entire complex, because the brain works when the hunger starts when the brain works. When I see jalebi, I feel hunger. When I see something which is say khatta mita, then I feel hunger in a pregnancy. Not me, but so this is a complex system, and it is not so easy to derive information from a single cell, and that's why this system is sometimes important. So what I am trying to say, there is no need to confront the two type of thinking discipline, thinking abilities. And this is where the animals testing is used, basic as well as a translational research. Basic research, without basic research, the understanding of the translational research cannot go. And pharmaceutical research and development, remember this, today incidentally, or I will not say unfortunately, many of the legal requirement of the pharmaceutical research is you have to do animal experimentation. And we have been asking that why? Then they say, give us the alternate system, which is equally reliable. So now here the challenge is that they say, the regulators say that I have to get the data from these and rat and mice, and I have to get data from monkey or maybe dog. We say that don't use it. They say that suggest alternatives. So that is a challenge for us. So that's what I said, the challenge. And toxicity testing, chemicals, cosmetics, and clinical entities. This is something very important where the in vitro or in silico experimentation give you the reasonable information which is sufficient enough for that. And that's why on that scientific basis, the toxicity testing in animals for cosmetics, for these things have been banned. Rightly so. There was a lot of, and so this is something very important, and all of you must think about it. Issues with animal testing, validation of animal experiments in human. That's what somebody says, that it translates 40%, 50%, 60%. Some will dig out the information that only 10%, but that becomes the beginning. Now, can you reduce that? Can you reduce the time frame of that? And can you increase the predictability of that? Is the ultimate thing. And so, who would be? Now, this is the popular slide which I made long back when I used to do experiments. And then see, this is one side, this is a rat, and then this is one side. You are developing a drug which will save a life of a baby. So what is the issue is, can you have to sacrifice this perhaps to save the life of this. The question is, can both of them thrive? Perhaps the answer is, people will say no, but I would say yes. Both of them can survive. And then the answer is that alternatives. If you have alternatives. And what alternatives? Remember, this alternative does not mean that you have to take Drosophila for everything. You have to do C. elegans for everything. Answer will not come. Here the answer is all procedures which can completely replace the need for animal experiments, reduce the number, 3R, of the animal required, diminish the amount of pain and distress. This is all replacement, this is all alternatives. And if you can reduce the number of rats being used from 100, now you can reduce just for 2 or 3 by getting the information from your in vitro or in silico tests, or maybe the computer aided modeling that can be. And so that's what, again back to our mentor, leader who started this society there. This is, all of us know, we should be proud of, this is the Indian laboratory. See, the research on alternative has progressed a lot in last 10 or 12 years. When I was director of IITR, which is Indian Institute of Toxicology Research, we started separated department for alternate to animals, and there was a separated task force given by Indian Council of CSIRC, Central Council of Industrial Research, to motivate people to work on alternate. And now we have all these animal models. Now we have in silico, we have a 2D in vitro. Now we are working on, everybody is aware of 3D models. And then also these are the lower animals. There are so many laboratories in India, including the academic institutions, the universities on Drosophila and C. elegans and Fitadia. All these things are at several places are available. The issue is, if these things are available at certain institutions, how can we transfer this information, technique or expertise to smaller institution or institution other places? And that's why the need of inter-university, inter-organization collaboration is. And I was just thinking that today the most common is zebrafish, which we do it, is being used at a large number of institutions. Including, I visited recently one of the pharmacy institute in Moga. They have a huge lab of zebrafish, and large number of publications are coming out of it. But the major limitation is the cost now. We thought that this is one of the least expensive. 10 rupees zebrafish has to be brought every time from Hyderabad, and then cumulatively the cost is very high because they are not able to breed so far. So can their institutional help can support that, how to breed it? Can the institutional help can tell us that what can be the other toxicity testing can be done on that, and can a consortium of this institution will help in validation or cross-validation. Working in publication in silos, working in silos is useless, just will give publication. But working together to validate a model is, I think, the need of the day. Computers, so many people are working, this became a fashion of getting M pharma, B pharma, computers designing for anti-inflammatory, for anti-diabetic drug, but for what? Unless you know how you are going to position this, how you are going to make this useful, unless you have, so what? You must have a question. If you are doing this computer designing, the concern is so what? And the next question should be what next? And these two things should be answered by those working this. This is in vitro. Now this is, we talk on that. Organ on chip model. And I am happy to witness I recently visited Jai Research Foundation in Vapi. It's a GLP accredited lab, and I happen to chairman of GLP technical committee. They have developed this organ on chips, and now they are validating this, and perhaps if such 2-3 organization, maybe CCMB, maybe NII, and maybe such a private organization can work together on organ on chips and develop organ on chips as many as, and validate them and make them available at the smaller institution, I think that's what perhaps is the need of the day. So lung on chips, we talk of lung on chips, we talk of liver on chips, we talk of brain on chips, gut on chips, heart on chips, and bone marrow on chips. This is not so easy to make these chips because so many circuits, so many enzymes, so many interconnectivity, and then these chips has to be reproducible for a specific purpose. So that is something very important. And this is a 3D organoid system, and again India is taking lead in this. That what happens that initially you have 1,000 compounds you have identified from in silico, and then you have brought down this to 100, and then in 3D cell base you can do whether it's 3D spheroid or maybe organoid, and then bring it to one compound or maybe two compound. So what has happened, if you just remember the first slide, you have reduced the number of the animal experimentation, maybe 1/100th of that. And then, even in this, if you can reduce the number of animal experimentation by using genetic profiling of these things, that will be much important. Now this is something, I'm not going into detail of this, but this is how chronologically development is taking place. Starting from the vascular multi-tissue organ chips, and now we have orthotrophic invasive dormant lung cancer chips, and so many chips are available. Today we still depend on the import of this. But what is required is how collectively we can work on these chips. Now this is a very important Nature publication which says that biodefense research, and this is Homo sapiens instead of saying Homo sapiens. So this is something very important. Now here you see that's what I said in the beginning. The bone marrow, this is a chip. There is a chip for liver, there is a chip for gut, there is lung, and then heart, and then the kidney. Now, if you connect them together, and then connect them together, perhaps which is missing link is here through the brain, then it will be Homo sapiens. And this connection is very difficult, very complex. Because if I see a lion, what will happen to me? What will happen to me? Or what will I do? I will do nothing. Whatever is to be done by lion, isn't it? That's what the common joke is. But that is what the sympathetic and parasympathetic system is. If I see a lion, my blood pressure goes up, my heart beats faster, the circulation in muscle improves so that I can run fast. My parasympathetic system gets also activated so that I get perspiration, and I get sometimes urination, defecation. Right? That is the parasympathetic system. So this is the complex system which can happen only when there is a complex integration of these chips. So working on these individual isolated chips is very useful, but at the end of the day, you have to know how to integrate this isolated information, and that is what the critical thing. That will become the caveat, but the caveat does not become you have to stop. Because the caveats are also there with the animals, caveats are also with their even the larger animals or multiple animals. So that is what important is. So this is replacement with the lower animals. So this is the organoid and this is the human. This is the replacement with the lower vertebrates, zebrafish, and I would say zebrafish, I call it as a low hanging fruit because this is easy to do, and even smaller places people have learned, mastered the technique of working on zebrafish. C. elegans, Drosophila. I used to wonder when I was in IITR, what is this Drosophila going to do with any investigation? This Drosophila is just like a maki. Working with maki is the most difficult thing. You know, maki is fly. But I never knew that this has so much of homogeneity or homogeneity with the larger, and it can even eye of Drosophila can give information of so much, and that is what important thing is. But so this is steps involved in developing alternate models. Develop alternate model. The important thing which we are missing in India, or we must promote in India, is the second, third, fourth step. The first step is easiest. The second step is difficult. Validation, pre-validation. Validation means at least 4 or 5 institutions should work in India. Then you validate within yourself, and then you validate with some outside agency, and then ultimately, important thing is the peer review and independent assessment. None of these papers have been peer reviewed independent assessment by a committee to see that, and then to recommend it to regulator that you accept this, replace this as this has been not done except 1 or 2 places. And regulator we have been talking, and the government is very keen to do that. And I was just informing Dr. Akbar Shah, the Indian Council of Medical Research has constituted a task force of that, and this constitution is now being finalized, and the meetings will be held. And the purpose of that, to find out who all are working in this and to do cross-validation, validation, and to make a case. If we can make a case, don't wait for the Western country, but make a case. Can we suggest this? So that is, we are not going to go this. There are several success stories, and this is an still challenge. Repeated dose toxicity, carcinogenicity, reproductive toxicity, toxicokinetics, the models have to be developed. So policy framework, alternate models, validated and accepted. The second is alternate models, validated, yet to be accepted. The third is alternate models being developed. We should know, we should maybe create just 2 rats or no rat, then there is a nothing risk which you are missing. So you have to just, when you are putting a regulatory framework policy document, you have to see that by doing this alternate, we are not missing any critical risk point, and we will be as sufficient in getting the safety data generated as it is. And then it will go into the regulation. So it is always from the lower evidence goes to the implementation policy. When it becomes a regulation, then you have to follow it. So therefore changing the regulation is a much more, existing regulation is a much more difficult, because for that change you have to generate a lot of data, a lot of information and a lot of validation. So that is what important thing is. A difficult thing, but society like this, the increasing strength of people working on this will make an impact.
Forum is open for the question, though we are running short of time. Any questions from audience? Yeah, ma'am, please. Can you be little loud, or you know?
We give you the
Seats from my side.
Hey, come on.
Sir.
Hello sir, very nice talk, a lot of wonderful points raised. I am Samantha. I did my PhD from CSIR IGIP. I worked with zebrafish for many years. So like you said, zebrafish can be a replacement for a lot of things, but even as a zebrafish researcher, we use a lot of animals. And the argument we sort of have in our mind is that these are animals which we grow for doing experiments. So it's not like we are really harming animals which are there in the environment. We are growing these animals for experiments, and then we are doing the experiments and then discarding them. So I just wanted to know what is your viewpoint on this. So yes, it's important to look for alternatives, but if these are animals which we grew for experimentation itself, so how do we then go about looking at this? What is your viewpoint?
Good point. I think this requires a lot of discussion, but my point is that when beagle dogs, when these are the inbred dogs, they are also grown for the experiments. So why we bother about it? They are meant to be sacrificed. So they are meant for the to sacrifice. But then they go to the first slide. Do we have this? Even if they are grown for the sacrifice, the soldiers which are fighting on the border, they are meant to fight and defend our borders, which may, this is implied that they may die. They may sacrifice. But do we accept the battle in the field without any justifiable reason? But if at the cost of defending our border, then that is acceptable. That's what we worship them. And so my point is, whether it is a dog, whether it is a rat, whether it is a monkey, even if it is bred for the experimentation, their life is as precious as not bred for the purpose. So that is important. So zebrafish, and that's why the philosophy, I understand, maybe Ankita and all those groups can debate on this. The lower the species, perhaps acceptability is better. And that's why if I find out something which is organ-achieved by amoeba, though it also has a life, then I would say that somebody can argue, amoeba may be the life hai. Why are you harming amoeba? But I am killing amoeba every day with my tronidazole, because it is harming me. So I think this is
Thank you, Dr. Samanta. This is very pertinent question, but we are using zebrafish and she have used a lot for
Yeah.
very good reason for rare genetic disorder.
Oh yeah, that's
Very, very good. But I have one question, burning question, sir. Policy maker, I being in FSSAI, but don't look to the scientific evidence as has been looked by. One example I want to give. There are many nutraceuticals which by the way of history of safe use somewhere else in the world is being used, and Dr. Ankita Pandey also wrote a lot about that one. Still do we need something which is being used extensively other part of the world? Do we need to go for the same kind of a testing if it has to come to India? Maybe something like that. But some evidence which are so obvious is not being looked after by the policy maker the way they need to be. This is, I am saying, from the food side, not from the drug side, sir.
I think Dr. Vijay has raised a very important point, and that's why it is important that the scientists like Dr. Vijay and maybe several others should be in the policy making bodies. I will just give you a more extension of this. In clinical trial, where I formed the regulations of 2029, which is now 2019, which is called as the NDCT regulations, I strongly argued that why you need to do a clinical trial when the drug is already sold for many years in US, USA, or maybe USA, Japan and all developing countries where the regulations are so good. How many drugs have been withdrawn because of the Indian clinical trials have not been found to be supporting this? Hardly any. So is it just a formal or customary repetition? We with great scientific background, we could add one line which is very important, that it's waiver, and that's also because a lot of NGOs, lot of science, lot of the strict people who just believe that it has to be continued, we could add that if a drug is already in the market of well-regulated countries for 4 years, that is the period which is considered a new drug, and we do not have an evidence that Indian population will have a different enzymatic setup to metabolize it differently, and there is no reason to believe that this drug will have a differential side effect or efficacy, the waiver can be considered provided there is an unmet need in India, like XY1, 2, 3, 4. So that is a step-by-step process. So I fully agree with Dr. Vijay that something is so, and that's what also many times we believe that thousands of years we have been using a particular Indian system of medicine. Why we need to repeat the same clinical trial steps? Maybe we can use a bridging study. So these are the very burning questions, but very pertinent question, Dr. Vijay.
Thank you, sir. I think Dr. Srijit is pointing that we should end it now. Thank you very much, sir, for that very wonderful, nice talks. And because sir sits in many committees, so it will be helpful for us to push our agenda of society for alternative. Thank you, sir.